Hello everyone. We are going to start with another lecture of performance management, and in this lecture we are going to deal with the concept of variance analysis. We are going to start with variance analysis today. Now, we first of all we are going to discuss mixed variance, right? A material mix variance and material yield variance. So as a starting, I just wrote all those things which you guys have already studied in F2 or FMA paper previously, right? We know that material variance is divided into two parts: material price variance and material usage variance. Price variance is the responsibility of purchasing manager. Why? Because purchasing manager is responsible for purchasing of raw material. So if standard price was $10 and actual price was $11, then this means that purchasing manager bought material at one price $1 higher as compared with the standard, right? Purchasing department manager spent $1 more as compared with the expectations, right? So we will classify that variance. We have classified that variance to be adverse, right? So whatever you are doing, whatever has been done in terms of purchasing is the responsibility of purchasing manager. So price is usually the responsibility of purchasing manager. Then we discussed that there is another variance which is called material usage variance, and usage variance is the responsibility of production manager, because production manager is responsible to change the recipe of the product, to change the ingredients of the product. So he is usually responsible for the purchase, for the consumption of raw material. So this is something which we have already studied in past in F2 paper, right? Now we are going to introduce two more variances in material variances, and these two variances are called, the first variance is called material mix variance, sorry, and the second variance is called material yield variance. And both are the responsibility of production manager. Why? Because these two variances are the sub variances of usage variance. So since production manager is responsible for usage variance, therefore these two variances are also the responsibility of production manager, right? Now the first thing that comes into our mind is that, what do you mean? What is material mix variance? What is material yield variance? Right? So let's start with the introduction of mix and yield variance. See, mix variance, these two variances only arise when company is using more than one raw material in its product. For example, there is product A, right? There is product A which require only one ingredient in its manufacturing. In that case, there will be no material mix variance and no material yield variance, because mix variance is actually related with how efficiently you are mixing two or three different types of raw material with each other in order to produce the output, right? So if you are using just one raw material, there is no concept of mixing in that. And if there is no concept of mixing in that, there will be no mix variance in that particular situation. So first of all, just remember that mix and yield variances are only calculated in a scenario when company uses more than one raw material in the manufacturing of the product. If a company uses three raw materials in the manufacturing of the product, you will calculate material variance and yield variance. If company uses just one raw material in the manufacturing of the product, neither mix variance nor yield variance will be calculated in that case, right? Now let's just start with the calculation of mix variance. Let's see what we can do in mix variance. See, for example, um, see, there is a very simple concept. Suppose there is a product, I'm just explaining what is the mix variance. Suppose there is a product which is called product A. Product A requires two ingredients in its manufacturing: raw material X and raw material Y. Right? it needs 2 kilograms of raw material for the manufacturing of 1 unit of the product, and the price of raw material X is $10. So that means what? That means $20 of material will be required for the manufacturing of 1 unit of product A. Similarly, suppose 4 kilograms of material Y is required for the manufacturing of 1 unit of product A, and its price is around $20 per kilogram. So 20 times 4 is around 80. So the raw material cost of this product is around 100. This is what? This is the standard material cost. So this means what? This means that the overall consumption, the total consumption should be total consumption is 6 kilograms, and out of 6 kilograms, 2 kilograms is raw material X and 4 kilograms is raw material Y. Now sometimes what happen is production manager, in order to save cost, or in order to for cost cutting, or maybe because of some pressure from the management to reduce, to cut down the cost, they try to change this proportion. What do you mean by changing the proportion? See, what they can do is, since they have the authority to change the mix of the ingredient, so what they can do is, they can, instead of inputting material in this proportion, what they can do is, they can input raw material X. They have seen that raw material X is a cheaper raw material and raw material Y is an expensive raw material. So what they did is that they reduce the quantity of Y, and they can increase the quantity of X in order to save the cost. For example, if they input 2.5 kilograms of X for the manufacturing of the product, and raw material, and approximately 3.5 kilograms of raw material Y, so what will happen? It Raw material X cost is $10 and raw material Y cost is $20. So 3.5 into 20 is approximately 70. So 25 plus 70 is 95. So see, what we did is, we just changed the proportion of raw material. Total consumption is still 6 kilograms. But instead of making an input in the ratio of 2:4, we actually made an input of 2.5 to 3.5. So we just changed the mix of raw material, and by changing the mix of raw material, by the way we are using the raw material, by just changing the mix of raw material, we have reduced our material cost by $5. So this concept you can also use in target costing. Now the question that comes into mind, now this is basically the concept of mix variance, that because of change of actual mix as compared with the standard, I mean the standard is suggesting you to make an input of in the proportion of 2:4, but you have changed the input of raw material. So by changing the mix of raw material, there can be some saving in cost, there can be some extra spending in cost. So that is basically the concept of mix variance. How much saving you are making by changing the proportion of mix of raw material, or how much extra money you are spending if you have changed the proportion of raw material. So that's basically the concept of mix variance. Now in this questions, something comes into our mind, that if we have changed this proportion of raw material, what will be its impact on the quality? Is the product will be of same quality, or if whether the product will be of inferior quality? I mean, whether the quality is will be compromised. It depends upon the product, to be very honest. But mostly, this is the mostly what happen is, whenever you try to save money by making an input of less expensive material more, usually in that case, you have to use more raw material. For example, for example, this is a cheaper raw material, and you input it in a higher proportion. So usually its result is that you have to use extra raw material. The consumption of raw material usually increases, and that's basically the concept of yield variance. So yield variance basically try to look at the fact that how much output should have been made by using the raw material, and how much output we actually got. And mixed variance actually measure the change of proportion in material mix of the product, right? So let's do a very simple example of this, right? Let's try to consider the same example, and let's try to do a question regarding this. See, suppose for example the company is using raw material X. The standard cost card says that raw material X, 2 kilograms of raw material X should be used at a cost of $10 per kilogram. That makes around $20 per unit, right? This is suppose product alpha, right? And product alpha require approximately 4 kilograms of raw material Y at a cost of $20 per kilogram. I'm just copying this example. This is standard cost. 20 times 4 is $80. So what we were expecting that the overall expenditure will be around $100 for the input of 6 kilograms of raw material, right? This is basically something which we are expecting. Now what actually happened is, see, suppose the actual information suggests that the output of product alpha was around 5,000 units, right? And company used raw material X and raw material Y. Company overall used approximately 32,000 kilograms of raw material, right? This is the usage. And company used approximately, let's say, 11,000 kilograms of X, and not 11, let's make it 12,000 kilograms of X, and 32 minus 12 is 20,000, and it used 20,000 kilograms of Y. Actual price of raw material was 11 pounds per kilogram, or let's make it 10.5 pounds per kilogram, and actual price of Y was around 20.5 pounds per kilogram, right? Now this is basically a very simple question, right? Now we have to calculate mixed variance. So try to concentrate on the steps how to calculate mixed variance. See, for the calculation of mixed variance, the first step is to calculate the standard percentage of input, right? Standard percentage of input means what? We need to check that how many kilograms, what percentage of the input of X is required and what percentage of input of Y is required. For example, raw material X, we need to input 2 kilograms of raw material X for 1 unit of the product, and 1 unit requires 6 kilograms. So if we are making an overall input of 6 kilograms, 2 kilograms must be X. That makes around 33.33%. And raw material Y is 4 kilograms out of 6 kilograms. That makes around 66.67%. So this means what? This means that the standard recipe is 1/3 or 33% should be X, and 2/3 or 66.67% should be raw material Y. This is what our standard suggests for the perfect manufacturing of product alpha. Now, let's see what actually happened. See, we actually made an input of 32,000 kilograms of raw material, right? So let's try to make another chart. We first of all we have to calculate standard, sorry, we have to calculate actual input in standard mix. Now, what do you mean by this? See, we actually made an input of 32,000 kilograms, right? So, 32,000 kilograms have been input into the process. We need to check that out of 32,000 kilograms, how many kilograms should be material X and how many kilograms should be material Y according to the standard recipe. So standard recipe says that look, 33% should be X and 66% should be Y. So what should be raw material X in this scenario? Raw material X should be 32,000 times 33.33. That makes 10,666. 10,666 kilograms of X should be in the mix, and raw material Y should be, this is kilograms, and raw material Y should be 32,000 times 0.66667 to 1,333. So 21,333 kilograms should be of raw material, should be raw material Y. So this is basically what? This is basically actual input in a standard mix. Whatever input we have made, that input should have been made in this proportion. Now, what we actually did is we actually input 12,000 kilograms of X and 20,000 kilograms of Y. So now we are going to compare this column with what we actually did. That means we have to compare it with actual mix or actual quantity used, whatever you want to write. Actual mix is 12,000 kilograms of X and 20,000 kilograms of Y, right? This means what? This means that we input 32,000 kilogram, but actual input is different from the standard. Standard is suggesting that 21 out of 32,000 kilograms, 21,333 kilograms should have been Y and 10,666 should have been X. But instead of this, what we did is we made an input of 12,000 kilograms of X and 20,000 kilograms of Y. So actually what we did, we actually changed the mix of the output, right? So let's see what is the difference. Difference is, now we have to calculate the difference. Difference is 10,666 minus 12,000. Difference is 1,334. Right? Now you have to check whether this difference is in favor or is in adverse. Favor in the sense that if you have consumed more actual quantity as compared with the standard, then it's an adverse variance. And if you have consumed less quantity as compared with the standard, then this variance is favorable. Now let's check. Actual consumption is higher than the standard consumption. Actual consumption versus a standard consumption, actual is higher. So we will say that this is towards the adverse variance, but this is not the variance. We are just trying to confirm what variance will be, whether it will be adverse or favorable. But remember, this is not variance, this is just the difference. Now what is the second one? Second one is 21,333. 21,333 minus 20,000, that makes around 1,333, right? So, and since actual consumption was lower, so you will say that this is favorable. But again, this is not variance, this is just the difference. Now what we have to do, we have to multiply both differences with the standard price. Now try to, just mark my words, we have to multiply this with the standard price. In question, examiner gave us actual price, actual price is given, and standard price is also given, but we will use what? We will use the standard price. Why we will use the standard price? See, the concept is very simple. These two variances are the subvariances of material variances, and in the calculation of material variances, usage variance, and in the calculation of usage variances, we use a standard price. So since usage variance involve the use of standard price, therefore we will use standard price in this calculation as well. So we can reconcile it. Now, what is the standard price? The standard price of the first product is $10, and the standard price of second product is $20. So just write it $10 and $20. $10 and $20. Remember, standard price. Don't write actual price. And then we will multiply these two columns. We will multiply these two columns in order to get the variance. Right? So 10 multiplied by the difference is 1340, and 20 multiplied by 133 is 26660. This is adverse and this is favorable. So favorable is more. One double three two zero. 13320. This is favorable. Why favorable? Because favorable is higher. Favorable is higher. That's why we are saying that overall variance is favorable. In case adverse is higher, then the variance will be adverse. Simple. Now, this 13,320 is called total mix variance. Right? Total mix variance is 13,320 favorable. Now, what do you mean by this? What do you mean by this statement that total material mix variance is 13,320 favorable? See, it's simple. If material mix variance is favorable, then this means, if material mix variance is favorable, then this means that company has used high proportion of low price material, or in other words you can say company has used low proportion of expensive material. Right? So favorable means what? Favorable means that we saved money by making an input of less expensive material in a higher proportion, and usually it compromise the quality of the product. Right? That's why we usually don't recommend unless and until that quality, in case quality will remain same or acceptable for the customer, only then we recommend it. Otherwise we don't recommend it. If this is the case that by changing the mix of raw material quality get compromised, so we prefer not to refer that point. Right? Now, so this is basically the mix variance. Now, what is yield variance? Now, how we will calculate yield variance? See, yield actually represent the output. If you ask anyone that what is the concept of yield, so yield actually represent the output. Right? So now we are going to calculate the yield variance. We are not dividing it, this is just an idea that we are going to calculate yield variance. Now it's very simple variance. first of all, you have to check that what should be the standard output. What should be the standard output? Standard output means what? See, one unit of alpha, one unit of alpha requires 6 kilogram of raw material, right? And we made an input of 32,000 kilograms. Sorry, we made an input of 32,000 kilograms. So if one unit requires 6 kgs and we have made an input of 32,000 kilograms, that means what? That means by using 32,000 kilograms, we should have made 32,000 divided by 6. We should have made 5,333 units of the product alpha. Right? So the standard output should have been around 5,333. Now what is the actual output? We have to compare it with the actual output. What is the actual output? Actual output was around 5,000 units, right? So instead of 5,333, we actually got an output of 5,000 units only. So this means what? This means that we got 333 units less than the standard. Now try to identify whether try to guess whether this variance is adverse or favorable. Adverse, obviously. I'm sorry, this is not the variance, this is the difference. But this difference means, this difference is indicating that the variance is going to be adverse. You may write adverse in a very small letter so that ultimately you can write it later in the answer. Now, so this is basically this 3,000. These 333 units are basically of product alpha. Now, what we have to do, we have to multiply this 333 with the standard cost per unit of alpha. Right? What is the standard cost per unit of alpha? Standard cost per unit is around 100. So we have to multiply it with 100. So if you multiply it with 100, 100 multiplied by 333, that makes around 33,300 favorable. Sorry, adverse. And this is what? This is basically the yield variance. Right? So what actually happened is, see, this is material mix variance and this is material yield variance. So the mix variance is 13,320 favorable and the material yield variance is around 33,300 adverse. So this means what? This means company's overall variance will be 13,320 favorable minus 33,300 adverse. That makes around 19,980 adverse. And this is representing what? See, initially what I said, that material mix variance and yield variances are sub-variances of usage variance, right? So if you add these two variances, you will get material usage variance. Right? So what actually company did, let me try to sum up this whole example. What company tried to did, what management tried to did, management tried to change the mix by making an input of low price material in higher proportion and expensive material in a lower proportion, and they thought that they can reduce the overall cost by using such step, and they did that, right? They actually saved 13,320 by changing the mix of raw material. But unfortunately, that result in that badly hit the output of the product. I mean, there is a wastage in the product, in the raw material, because instead of producing 5,333 units of the product, they only manufactured 5,000 units of the product. That means material, we were unable to make, the actual output was 333 units less as compared with what it should have been. That means raw material equals to 333 units got wasted, which has not been converted into the finished product. So that is basically a loss to the company, and that loss is higher as compared with the mixed variance. So overall, financially, if someone asks me whether this policy was in favor of company or not, I will definitely say that no, this policy is not favorable. Wasn't favorable for the company, because overall company has to suffer extra cost. Overall cost has been increased, and remember, we haven't considered the quality issue here. Maybe quality has also been compromised by changing the mix of raw material. I don't know. See, in Pakistan, there is a very common phenomena. I mean, probably I shouldn't have given this example, but still, there's a very common phenomena in Pakistan. In Pakistan people sell milk in normal shops. I mean, there is no Tetra Pak available. Tetra Pak is available, but there is another type of selling here, which is the open milk. I mean, not in Tetra packing. So what they do is they mix some water in the milk, because water is cheap in Pakistan. So ultimately, if I'm just giving you a very stupid example, but this is a real example. For example, they took 2.5 liters of pure milk, and they input 0.5 liter of water in that, and they come up with 3 liters of milk, which they can sell it to the customer. So what they did is they actually made an input of a cheap raw material into their finished goods. And what will happen? This is going to save. This is going to bring saving for the company, for them, because it's going to reduce the cost, because water is easily available here. But definitely that's going to compromise the quality of the product. Quality of milk, the taste of milk get compromised. So that's basically an example. Another example is used in construction industry. In construction industry, whenever you build any wall or anything, there is a standard proportion of cement and bajri. Sand. Sand and cement got a proportion, standard proportion. But if you input more sand and less cement, if you mix, if you in the mixture, if you input more sand and less cement, you will be able to build the house. You will be able to build the wall, but still the quality of that wall will not be good in that case. So sometimes it happens that that you try to save, in order to save the cost, you input low quality material in higher proportion. In that case, mixed variance get favorable, but ultimately in majority cases that adversely affect the yield variance, right? So that's the end of this video. In the next video, we will do one more example of this mix and yield variance, and then we will do few questions, and then we will discuss one more issue in this, and that is the concept of losses, right? So till then, have a nice day, take care, have a nice day, Allah Hafiz.